Right now, there are more stars in the observable universe than grains of sand on every beach on Earth. 200 sextillion of them, and almost every single one is different. Some will outlive the universe itself. Some exploded before our solar system was even born. This is every type of star, explained. Eventually, the core reaches 10 million degrees Celsius. Nuclear fusion begins, and a star is born. But not every collapsing cloud makes it that far. Brown dwarfs are what happens when a protostar doesn't have enough mass to ignite proper fusion. They're bigger than planets, but smaller than stars. Technically, they failed. They tried to become a star and didn't make it. They still glow faintly from the heat of their own formation. But that heat is slowly fading. In a few billion years, a brown dwarf will be cold, dark, and invisible, a ghost object drifting alone in space. Red dwarfs are the most common stars in the universe. About 70% of all stars are red dwarfs. They're small, between 10 and 50% the mass of our sun. They burn so slowly, so carefully, they barely glow. A red dwarf can burn for 3 to 10 trillion years. The universe is only 13.8 billion years old. Orange dwarfs might be the best stars in the universe for life. Bigger than red dwarfs, so planets orbit at comfortable distances. Smaller than yellow dwarfs, so they burn longer, up to 30 billion years. More time, more stable, more opportunity. Some astronomers think orange dwarfs, not yellow ones, are where we should look for alien life. The Goldilocks star. Not too hot, not too cold, burning for an almost unimaginable span of time. Above a certain mass, stars burn hotter and whiter. Sirius, the brightest star in our night sky, is a white star. It burns at over 10,000 degrees on its surface. Our sun is about 5,500. Sirius is twice our sun's mass and 25 times as luminous. Blue-white stars push this even further. Surface temperatures exceeding 20,000 degrees, they blaze with near ultraviolet intensity, and they burn fast, tens to hundreds of millions of years. The hotter the fire, the shorter the flame. Blue giant stars are among the most powerful objects in the galaxy. Some are 20, 50, even 100 times the mass of our sun. Surface temperatures exceeding 30,000 degrees, luminosity up to 1 million times brighter than our sun. But that power comes at a cost. A blue supergiant might only live a few million years. They burn so intensely, they consume themselves at catastrophic speed. Where our sun gets 10 billion years, a blue supergiant gets maybe 3 million. Then it explodes. That explosion is called a supernova. For a brief moment, one exploding star can outshine an entire galaxy of 200 billion stars. Red supergiants are the largest stars by volume in the universe. Betelgeuse, the red star in Orion's shoulder visible to the naked eye, is one. If you replaced our sun with Betelgeuse, it would swallow Mercury, Venus, Earth, Mars, and reach toward Jupiter. Betelgeuse is 700 times the diameter of our sun, so large that light takes hours to cross from one side to the other, and Betelgeuse is near the end of its life. When it explodes, it may be visible in our daytime sky. When a massive star dies in a supernova, sometimes the core survives, crushed to unimaginable density. The result is a neutron star, about 20 kilometers across, the size of a city, but containing more mass than our entire sun. A teaspoon of neutron star material would weigh 1 billion tons. They spin hundreds of times per second. Some shoot beams of radiation from their poles like cosmic lighthouses. We call those pulsars, the most extreme stable objects in existence. When the most massive stars die, the core collapses so extreme that not even atoms can stop it. The core compresses beyond all known limits. A singularity forms, a point of infinite density, surrounded by an event horizon, the point of no return. Anything that crosses the event horizon never comes back, not because it's trapped, but because beyond that boundary, all paths in space-time lead inward. There is no out, just endless, silent collapse. When the universe was only a few hundred million years old, the first stars ignited. They were unlike anything that exists today, made almost entirely of hydrogen and helium, no metals, no complex chemistry. Some may have been hundreds of times more massive than our sun, burning at temperatures we've never seen since. They lived fast and died violently. Their supernovas seeded the universe with the first heavy elements: carbon, oxygen, iron, the building blocks of everything that came after, of planets, of life, of you. Every atom in your body was forged inside a star, and the very first stars made it possible. From protostars that never quite ignited to neutron stars spinning hundreds of times a second. From the red dwarfs that will outlive everything to the first stars that made everything possible, every single one of them burning through the dark, and our sun, average, unremarkable, sitting quietly in the middle of all of it, keeping us warm. Which type of star would you want to orbit? Let me know in the comments. A teaspoon of neutron star material would weigh 1 billion tons. They spin hundreds of times per second.